Question number 3 says a car is moving away from a motion detector with a constant speed. Now look at, when they are saying with the constant speed, it will be definitely, it will be go in a linear way. A car is moving away from a motion detector with a constant speed. Which graph best represents the motion of a car? So which graph represents a motion of a car? And again, look at here, moving away with the constant speed. So its car is going away from the object, that is the motion detector. Let's take, suppose if this is the object which is representing the motion detector, and car should go away from it. It should go away from it is means what happening, as the car moving away from it, so as the time is increasing, the distance is also like further distance is also increasing. It's going away from it means as the time increases, the distance is also increasing. That is what we need to predict. So if I'm representing that's in terms of a graph, if I'm representing this in terms of a graph, a distance versus time, so what happens at initially, as I said, this must be a linear at initially, so it will be starting at the initially when we are talking from this point. At this point, consider the car is exactly and at the detector, that's the distance is 0 and time is also 0. As it is going away, it means distance is also increasing and the time is also increasing in this way, isn't it? So now it's from the initial, as it's going away, as the time increasing, so distance also increases. So this is how the graph is going to be. Let's say time is equals to 1 second, it may cover a distance of 1 meter. Time is equals to 2 per second, it may cover a distance of 2 meter, and so on. It's basically, it is a linear motion, right? So now which graph is going showing in this way, that itself is your answer. So out of A, B, C and D, what we can see here is B is the way it's showing in this the time distance with the time relation. So B is the right answer here. Now why can't I go with A? Because A is also representing a straight line, but it's in opposite way. So what actually A is representing a situation where a car is going towards the motion detector. If I'm saying, so this is the motion detector for, I'm talking about A, and if the car is going towards it, as it is going near to it, so what happening, as the time increases, the distance towards the distance is decreasing. Look at, distance is decreasing and the time is increasing. As if I'm talking about, let's take, at the time is equals to 1 second, distance was something 10 meter. At the time is equals to, let's take 5 seconds, distance was just like 5 meters something. At time is equals to 10 second, distance may be 1 meter, and so on. As what happening, as the time increases, distance decreases. This is talking about the car is moving away from the motion detector. That's why this is not the correct one. C is not the linear motion or the linear momentum. It's basically, and the curve is showing an exponentially, means it is not with a constant speed. This is not with the constant speed, it is with the variable speed, but the question mentioned here is with the constant speed. So that's why C cannot be. And the D, it says like the object is at rest. As the time is increasing, but there is no change in the distance covered. It means basically, if here is a motion detector, here is a car, it's not moving, it just it's at rest. So that is how option D is says. So D is also wrong. So the best choice to this question here is option B.